Hello everyone, welcome to the presentation of EldenBossBuster. Elden Ring, well known as a soul-like hard game. People are required to beat hard enemies with high degree of freedom. And due to its high difficulty, people may find it frustrating and time-consuming to search for a strategy to beat a particular boss. So our goal is to make a recommendation system that based on players' current status, based on players' input, including their current status, their goal, and the boss they're gonna face. And like in this example, we have provided the weapon data, the weapon name, the boss name, and the goal. And it will come up with the output with modules of strategy, equipment, skills, and tips with a good readable format. And this is how it looks like. And also we have come up with the input data set for evaluation, which contains several different questions that people may ask. And to achieve data, we are calling YouTube transcript API for grabbing transcripts and using GPT to clean the data. And this is one clip of our clean data. And also we have downloaded the cargo system, the cargo data, and we called GPT to change the format of it to make it more readable.
We have developed a command line interface and a GUI for displaying player input, system output, and chat histories. Our architecture consists of 7 agents grouped into 4 groups. First, we have the base strategy agent that recommends the strategy based on the player input. Then we have the strategy query agent that generates a query based on the initial query and the recommendation. It tries to add additional details. The new query and the initial recommendation is then passed to the strategy rec agent that generates a more refined recommendation based on the community guide rec database. After that, we have the game info query agent that generates a query based on the previous recommendations and queries. These queries and the previous recommendations are then passed to the game info rec agent that generates a more refined recommendation based on the game info rec database. The loop response agent then tries to evaluate the response based on its relevancy. If it passes the requirements, it's delivered to the user. Otherwise, it signals the base strategy agent to generate a more revised strategy. If it still fails after 3 iterations, it's then sent to the final response agent. The final response agent signals the user that the feedback is needed. Any new feedback will restart the loop.
So our quantitative testing focuses on these 2 key areas, the rec performance and the overall system performance. And this is the rec triad. It has 3 key elements: the query, the retrieve context, and the response. This matrix between each pair evaluates the relevance between each pair to ensure the overall quality. These rec triad scores range from 0 to 1, and as you can see, both rec systems have low context relevance and groundedness. And I think it's because the YouTube transcripts in strategy rec are too generalized for specific user queries, and game info rec focuses on item details, lacking relevance to actionable guide. And for in-game testing, we use this rubric to evaluate, and it focuses on 3 aspects: strategy clarity, the executability to win within 20 attempts, and the feasibility based on the player's stats. Overall, the system achieved a 70% success rate in 10 examples. For this test, Huairu and Dai follow the recommended strategy, and the other 2 members use their own build to try to beat this new boss, Dancing Lion, and the results show that the guide can reduce the number of attempts. It also highlights the effectiveness of guide.
Okay, we have a good example to evaluate the system quality. This is the input. We can see some keywords like the strength and the vigor and the magic resistance that the user needs. And this is part of the output that related to the keywords we have. And we can see the Night Shield is provided for the magic resistance. Overall, this good example provides evidence to show that our agents are worked properly as expected. The first one shows the base strategy agent was able to understand the user's build and provide basic recommendation. And the second one shows that a specific location can be retrieved from the game info REG. And the structured combat strategy is well retrieved from the game strategy vector space. However, sometimes the game info reg is not useful enough. We need to find a better way to retrieve this kind of data, maybe implement agent function calling or use SQL query. And we also want to increase reg database from YouTube or other sources. And the reg seems to limit the knowledge of the model. So we need this kind of hybrid architecture for both direct answering and reg. Currently, we use a GP for the base strategy agent to do the direct answering. And the detailed architecture can be improved in the future. That's all. Thank you.